Hello and welcome to ChemCAD tutorial session number 3. In this session we will be learning on how to simulate flash tanks into ChemCAD. So let's say you have this kind of problem in your class and you're asked to solve the problem using ChemCAD or to simulate your result using ChemCAD. So let's say you have a feed composed of benzene, toluene, and ethylbenzene where the feed temperature is 25 Celsius, pressure is 1 atmosphere. The total flow of the feed is 100 mole per second, and the mole fractions are zero point 0.3 for benzene and toluene, while zero point 0.4 would be for ethylbenzene. And after doing your calculations, you find out that V over F equals zero point 0.5. So the vapor fraction is zero point 0.5. So let's go to ChemCAD and try to simulate that process. First, let's check our units and go to Format, Engineering Units, and because we saved it last time, we would have the same units again. So let's go to OK. Now let's add our components. So let's go to Select Components, add benzene, toluene, and ethylbenzene. Again, ethylbenzene won't come out the first, so we'll have to hit Next. This is ethylbenzene. So we have the three of them now. Let's hit OK. Click OK again. And it will again suggest an RTL. We'll change that to UNIFAC. And we'll choose the global phase option to be vapor liquid, liquid solid, because we will have a vapor liquid equilibrium. Let's go to OK. So let's go to the new part. Go to the icons on the right hand side and find the big arrow that says feed. Click on it and then go to the white space and click on it again. Now find the big product arrow. Again, click on it and then place it on the white. So now let's go to the new part. Let's go to the icons on the right hand side and find the big arrow that says feed. Click on it and then go to the white space and click on it again. Now let's find the big product arrow. Place two products arrow on your white space. We also have to note that these are not process streams, but they are more like storage tabs. If you need to stop dragging the things around the white space or the icons around the white space, just right click. You could also search or find unit ops using the search bar, so let's look again for feed and it will come up again. So now let's find the flash number 1 icon and place a flash tank on your white space. So flash and place it on the... Again, try to not place the flash tank right next to your large feed or product arrows. Remember, these arrows are not process streams, but are more like storage tanks. Now let's find the stream icons and click on it. So let's search for streams, and this will be your stream icon. So let's move it to the white space and try connecting the feed, the red dot of the feed to the blue dot of the flash tank. And then the red dot of the flash tank to the product arrow, and the other red dot for the product. You can also see that you can add 4 feeds or 4 inlets for the flash tank number 1 and 3 products, but in this case we will only have 2 products because you only have vapor outlet and liquid flash outlet for each product arrow. To edit the feed stream properties, you have 2 options. You can go to the red arrow near the upper toolbar and click on it, which will let you enter data for your feed streams. Or you could simply just double click on the feed stream arrow and add or enter the following stream data. So let's enter the stream data. We have a 25 Celsius temperature, a 1 atmosphere pressure, and a total flow of 100 moles per second. And the mole fraction are 0.3 for benzene and toluene and 0.4 for ethylbenzene. Click OK. Now once we set our stream feed properties, we can go ahead and edit our flash tank properties or specifications. So let's right click on the flash tank and select Edit Unit Op Data. A window for setting the specifications for the flash tanks will open up. Depending on the type of the problem, you choose the specific flash mode that applies to your problem, or the one that best suits your statement. Since we already know the vapor fractions and the pressure, let's choose the first option. Of course, we assume that pressure is the same throughout the process and the temperature will be obviously changing. So as given in the problem, the mole vapor fraction is 0.5, the pressure is 1 atmosphere. Let's click OK. Now all of our unit ops are ready and we can start the simulation. Clicking on the big green arrow icon near the upper toolbar will run your simulation. This window will give you information about your simulation and whether there are errors or warnings in your simulation. So if you violated the second law of thermodynamics, it will run it and will tell you that your process violates the second law of thermodynamics and you will have to adjust your numbers. So after you run your simulation, let's place the mouse arrow over the flash tank. A window will open that lists the basic results of the simulation block. Notice that the flash calculations gives you the K values also. If you place your mouse arrow over one of the product streams, you should get a summary of the data for that stream. Another way of reviewing the stream compositions and a useful way to know if my simulation ran as I wanted it to be is by going to reports, go to stream compositions, and then all streams. So this is the stream table for your process. It gives you all type of information about your process and about your inlet and properties. You can always edit the numbers in this stream table by going to report and format reports. So usually I like two significant figures, and for fraction format, let's say three significant figures. And you can adjust these also. It gives you also a sample of the flow rate format or the fraction format. Let's keep it as it was. Now let's go again to stream composition, all streams, and we have the significant figures we wanted.